Hey there, and welcome. All around us, there are these invisible forces, these scientific principles that are constantly shaping our world in ways we barely even notice. Today, we're going to pull back the curtain on one of the most powerful, a force that's at play in your fizzy drink, in the deepest parts of the ocean, and even in some amazing life-saving medical treatments. So let's dive right in.
Okay, so let's start with a really simple question. You've seen this a million times, right? You crack open a can of soda and poof, it just erupts with all those bubbles. But why? What is actually going on in that moment?
It all comes down to that one sound. You know the one, that sharp sst. Well, that's basically the starting pistol for a really fascinating chain reaction. It's the sound of pressure being released, and honestly, it's the key to understanding everything we're about to talk about.
All right, so let's finally reveal the secret behind all that fizz. We're going to use this totally normal, everyday can of soda to unlock a fundamental law of physics.
So, picture this. Inside that sealed can, a ton of carbon dioxide gas is packed in there under really high pressure. This pressure literally forces the gas to dissolve into the liquid, where it just kind of hangs out, totally invisible. But the second you pop that top, the pressure inside suddenly drops to match the normal air pressure outside. And all that gas? Well, it can't stay dissolved anymore, so it has nowhere to go but out, escaping as all those tiny bubbles we call fizz.
Now, this whole thing isn't just some clever trick soda companies came up with. It's a real phenomenon, and it's governed by a very specific scientific principle. It was first documented by an English chemist named William Henry, way back in 1803. So yeah, it's time to officially meet Henry's Law.
Okay, deep breath. Here's the textbook definition. Yeah, I know. It sounds super technical, right? You've got phrases like partial pressure and in equilibrium. But don't worry. Don't let the jargon scare you. We're about to break it all down. We can boil all of that down to a much simpler idea. Okay, here's what it really means. It's super simple. High pressure squeezes or dissolves more gas into a liquid. Low pressure lets that gas rush back out of the liquid. That's it. That's the core of Henry's Law. High pressure in, low pressure out.
But what happens when the liquid we're talking about isn't soda? What happens when the liquid is our own blood? Well, that's when this simple rule can go from creating some fun fizz to creating a genuine life-or-death situation.
Think about a deep-sea diver. As they go deeper, their body is literally like that soda can. The immense water pressure around them forces extra nitrogen from the air they're breathing to dissolve directly into their bloodstream. Now, while they're down at depth, that's totally fine. But if they come up to the surface too fast, that pressure drops, suddenly, just like opening the can. All that dissolved nitrogen rushes out of their blood, forming these tiny, painful, and really dangerous bubbles in their tissues and joints. That's decompression sickness, better known as the bends, and it can cause some seriously excruciating pain or even paralysis.
And believe it or not, this whole thing works in reverse, too. If you go climbing up a really high mountain, the exact opposite happens. The atmospheric pressure is lower up there, which means less oxygen can dissolve into your blood with each breath. This is what causes altitude sickness or hypoxia, and it's why climbers can feel dizzy, weak, and just fighting for air. So you see, it's these two extremes, right? High pressure way down deep and low pressure way up high. Both show just how critical this gas pressure balance is for our survival.
So that gets you thinking, right? If this invisible force, this pressure, can cause so much harm just by messing with the gases in our blood, could we, flip the script? Could we actually use that exact same power to heal?
And the answer is a huge, resounding yes. In the world of medicine, we can actually harness the power of pressure with incredible precision to help heal the human body.
This is where we get into a field known as hyperbaric oxygen therapy, and it is a perfect, direct application of Henry's Law.
So, inside one of these special hyperbaric chambers, doctors can increase the atmospheric pressure way above normal, all while a patient breathes pure oxygen. And thanks to Henry's Law, this high-pressure environment allows the blood plasma itself to dissolve way more oxygen. We're talking 10 to 15 times the normal amount. It's just incredible.
And this supersaturated, oxygen-rich blood, well, it can get to damaged tissues that the normal circulatory system just can't reach. It promotes healing for all sorts of things, from really serious infections to stubborn wounds that just won't close. We are literally turning the body into a high-pressure container of pure, healing oxygen.
Okay, so let's bring it all home. After all that, why does understanding this one single law actually matter so much?
Because when you strip everything else away, it all comes down to this one simple, powerful idea. The amount of gas you can get into a liquid depends directly on the pressure you apply. Higher pressure means more dissolved gas. It really is that simple, and that unbelievably profound.
Think about it. From that satisfying fizz in your favorite drink to the deadly risks faced by divers and mountaineers, all the way to cutting-edge medical treatments that are saving lives, this one simple principle is the invisible force working behind the scenes.
So now you're in on the secret. You know what's behind the fizz in your drink, and you'll probably start to see the power of Henry's Law in all sorts of places. Pressure is this invisible force that's constantly shaping our world. And it really makes you wonder, doesn't it? What other fundamental rules like this are hiding in plain sight, just waiting for us to connect the dots?